Okay. All right, girls. In my email, I'm sorry, in the assignment, y'all notice that I just went ahead and gave you the formulas for arithmetic sequences, and I think I had thrown them or said I'm going to stand here and write them, at the end of the video or whatever. Okay. Not big on actually knowing the term formulas. In fact, sometimes I think it could get in your way, as opposed to just understanding the critical thinking. I intentionally did that the other day where you didn't know a formula yet and you performed great on the board on girls, really until number 28, just as challenging problems as the ones you have on your worksheet, but while you were just standing there thinking through it, you were fine, okay? So I'm not a big fan of the term formulas, but if you want to memorize them, well, it's funny, once you see it, you kind of memorize it because you understand it. If you just flat out memorize the formula, you could forget the formula and go, wait a minute, is it n minus 1 or n plus 1? Which is kind of ridiculous once you understand where this comes from. All right, so if I say 4 plus 3 is 7, plus 3 is 10, plus 3 is 13, plus 3 is 16, okay? How did I get to 16? Here's my first term. What did I add? How many 3's did I add to get to the second term? 1 3. How many 3's did I add to get to the third term? 2 terms. So girls, if I give you the first term and I want you to get to the fifth term, you only have to add 4 D's, right? Because you already have the first term. Do y'all see what I mean? Okay? So I need to add 1, 2, 3, 4 to get to the fifth term. That's how they know the formula. It's nothing fancy. All right? I don't even have to prove it. I mean, it's just common sense. All right? So A sub n to find any term that you already have decided is arithmetic. This only works with arithmetic. Well, you take your first term, and you've got to add d n minus 1 times. Make sense? Everybody okay with that? All right, now if I want to go from a sub 1 to a sub 5, I'm going to need to add 4 d's. If I want to go from a sub 3 to a sub 17, I'm going to have to get 14 more spaces. Are y'all okay with all that? You were doing that naturally the other day. Does that make sense? Let's cut it down some. A sub 7 to a sub 9. I think I'm going to need 2 d's. Sorry, I wrote this really bad. 14 d's from this number. 2 d's from that number. Is that true? A sub 7, a sub 8, a sub 9. Do I need 2 d's? But how many terms are there? 3. All right, so to see how much to add, you can always just subtract, which Belle was doing naturally the other day. Some of you maybe were also. I just happened to notice that with her. 9 minus 7, you need to get there, you need 2 d's, but how many terms are there? There's 3, okay? So if you have 17 minus 3 is 14, but there's 15 terms because you've got to count the first one that you start with, which is a sub 3. Y'all see that? Okay, so to get the number of terms, when you got to sigmas, if I've got to start at 21 and end up at, let's start at 20 and end up at 100. What's 100 minus 20 is 80, but there's 81 terms. Okay? How many terms are there from 1 to 20? There's definitely 20 terms, right? But what's 20 minus 1? 19. But you know there's 20 terms, right? All right, so when you say 20 minus 1, you're counting how many spaces you need to go to get from the term you started with. So you've got to count the term you started with. So if you want to know how many terms there are, you can subtract and add 1, but hopefully you know why that is so that you won't forget it. Some girls that were able to come out today for a little snippets of time, I actually said, if you get confused, back it down to a short number of terms from a sub 1 to a sub 5. You only have to move 4 spaces, but aren't there 5 terms? 5 minus 1 is 4. That tells you how many d's you need. 5 minus 1 is 4, plus 1 is 5 terms. Are y'all with me there? Hopefully you got common sense, okay? But anyway, here's the formula. Do y'all realize, girls, I want to go. Duh. Okay? If you give me the first term, and I already have the first term, don't I need to add n minus 1 of those d's to get to the term you want me to? I mean, okay, I got that. If you give me the first term and I need the 15th term, don't I need to go 14 more spaces? I got that, okay? I would say in later problems it's nice to know the formula, whether it's common sense or memorization, because you have to find different things about it. You'll use this formula sometimes even when you're trying to find something else. Y'all know on the test and on worksheets, when I was teaching the area of a triangle, it happened on the test also, where you know you need a 1/2 AB sine C, but I didn't give you that. And y'all remember you had to stop and go use another formula to find the given information. So this can help you get information you need for the sum formula. The sum formula I have not derived for you or shown you why it happens. And the sum formula, I would just flat out memorize it. N over 2 times the first term plus the last term. Now, I know some of you see things in different places. You have like places that you like to go, like Khan Academy or Cool Math or Purple Math or whatever. Okay, or a lot of you don't. Our book, I think, only has this formula in it. There's some books that also give an alternate formula. Again, I would say, no, I mean, don't memorize that, girls, okay? That means if I don't know A sub n, which happened on your worksheet, if I don't know A sub n, like suppose I don't know the last term, I may have to go off and find it. Do y'all see what this formula is saying? Is the number of terms over 2 times the first term, and like, oh my gosh, I don't know the last term, so I got to stop and find it. And A sub n is my first term plus n minus 1 times d. You don't need to memorize a formula for that, but you see you get 2 A sub 1's? So I would not memorize that. I would just use common sense and go, oh wait, I'm going to go find the last term and put it in here. And by default, you'll be doing this. Okay, so I don't, but I just wanted to say that tutors, SAT prep, whatever, you might see that second formula. You don't need to memorize it. Common sense is going to tell you to go find that. Okay, so these are arithmetic. Let me go on and talk a bit about geometric because you'll probably have some geometric homework tonight. So I don't want to be throwing that in my classic end of the class. You know, I know. Okay. If I have 2 times 3 is 6 times 3 is 18 times 3 is 54. And right now this is the first term and this is the second term. This is the third term. This is the fourth term. It's geometric if I can divide each term and get the same ratio to see what I was multiplying by. Common sense? Okay? Sometimes you can't tell if it's geometric because you might be multiplying by 1.7. But you'll know if you start dividing backwards and get the same number every time. It's also valuable and it helps you find out what your ratio is. I'm calling it a ratio because everybody else calls it a ratio, but also because it is. Isn't that what's happening when I say 6 over 2 or 18 over 6 or 54 over 18? I'm getting a ratio of 3 to 1. Okay? All right, so we call it a ratio in geometric. All right, let's develop the formula. To get to A sub 4, I multiplied by 3 how many times? So to get to 54, to get to the fourth term, I took the first term and I multiplied by the ratio how many times? If I already have the first term and I want the fourth term, I only need 3 more. Make common sense? Duh, right? If I give you the first term and want the 85th term, you've got to multiply 84 times. Okay? By the way, these can alternate in sign. If this is negative 3, what's 2 times negative 3 is negative 6. What's negative 6 times negative 3 is positive 18. 18 times negative 3 is negative 54. Negative 54 times negative 3 would be positive something. Did y'all see they can alternate? Which is a big deal later, okay? So what's our formula? To get any term on geometric, start at your first term, multiply by r, n minus 1 times. Memorize it or don't, it's up to you. It makes perfect sense, okay? The sum of a geometric series, which I didn't give you any homework on yet, is a sub 1 times 1 minus r to the n over 1 minus r. And then there's another one.
Only the r is to the n in that?
Yeah, and what's interesting here is be careful. This is the one of the only formulas you run into in series that doesn't have a minus 1 in it. Okay, but you don't want a minus 1, girls, if you're summing up all of the numbers, right? Look at this weird little thing. I use this over and over and over again for the next few months in calculus, next few weeks. This one over and over and over again. Give me a subscript. Zane, you give me a subscript. Give me a number. 3. So this would be the sum of 3 terms. Zane would take her first term, 1 minus her ratio to the 3rd power over 1 minus her ratio. And it'll add up all of the terms for her. It will get a sum. So what in the world does that mean? What's it missing? If I just said find the sum, what would you want to ask of me? The sum of an infinite number of terms. It's the flat out sum of the entire thing. But the only way that's going to work if the absolute value of your ratio is less than 1. Less than. If your ratio is greater than 1, is there any way if I put, girls, watch right here, if I put dot, 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 that is not going to do, here's a new word, that is not going to converge. Okay? It's going to do what we call diverge if you think of things getting bigger and bigger and bigger. Remember how we talked about the basketball? If I bounce the ball, here we go. Okay? So mathematically, you can actually like measure the distance with a motion detector. And I can go, oh, I did it, so it's bouncing half as far as it did before. Okay? Imagine what's going to happen to that tennis ball. I think I gave you the running example the other day, didn't I? Okay? So, you sort of start to stop being a math, which is funny because you feel like as you go into pre-calculus and calculus that you become more of a math nerd, you become less of one, and you start to do magic things, like add up an infinite amount of numbers. My students right now are finding area and volume by adding up an infinite amount of things in a finite space, which is impossible. They're finding an equation of a tangent line with just 1 point, and that's impossible. Like, what if I told you to find the equation of a line at the point 4, 7? You need another point, right? So you become like superheroes, all right, or magicians or something. It lends itself to more creativity, and it also stops the conversation of something like 3.9 repeating. 0.9 repeating, girls, is 1. That's very upsetting to some. I've been argued down, upside down, inside out on that one before by some of the brightest minds in the universe. But we can prove it. 0.9 repeating is 1. And at some point, don't you want to just go, people want to look at us math nerds and go, who cares? If I have 0.99999999999999999 cups of water, I've got a cup of water. I mean, you want to go, come on, just add another drop. Would you even know? And would it be a drop? It would be an atom, and then what would it be? It'd be half of an atom. Did y'all see what I'm saying? So it sort of lifts the math nerdness off of you, okay? In fact, there's a word that I'm going to teach you in a few weeks called limit. And it just like puts this cape on you that lets you do impossible things. It should get you all the cape. One year I'll do that maybe. But you put this cape on and you become a superhero, and you also get to take your nerd, glasses off with the tape on them right here and live with everyone else and go, but this is how it's behaving, because we'll never get anywhere if we're always perfect and meticulous. If we go, oh, well, I got 3.999999, an engineer can go forward with the number 4. Now, if I got 3.87, I probably don't need to do something with 4, whatever it is that I'm building or doing or prescribing. if it's 3.99999, are you going to know the difference in that and 4.00001 or 4? Okay, I'll teach that a little bit when we get to limits. But I got kind of off on tangent. The point is I'll show you. It's got to be getting smaller to converge on a number. Okay. All right. So we'll do it together in just a minute. I'll have you get out. I'm going to get our calculators while I answer Elena's question.
So
Elena?
what would the A of n not formula, but whatever formula be for this specific sequence?
For this one?
Yeah.
Oh, well, if I asked you to find a sub 6,
Uh-huh.
you would say 2 times negative 3 to the 5th power. If r is negative 3. Is that what you were asking me?
Well, yeah. No.
For
so
this
A of n equals with numbers.
Okay, what now?
When I don't know how to describe A of n equals n 3 to the n minus 1. What would it be for this one?
You know how you're multiplying it and it's like
Oh, are you talking about if it's infinite?
No,
Oh.
this is the n power.
now you're adding it's
With
if you're
numbers.
adding 3 it's 3n.
Find the nth term in the sequence when you're given A1 and A5 and you write AN equals 5n minus 9. What would the
Say it again.
these
Just read it out loud to me.
so A1 equals negative 4 and then A5 equals 16. So you know A of n is 5n minus 9.
A of 5 is 16?
Yeah.
Okay, but that's an arithmetic
No, I
sequence.
know. So
If
A
it
of
was
n is-
geometric, I would go 16.
No, I know.
Okay, go ahead.
So then A of n of an
A sub n?
Yeah, A sub n would be 5n minus 9. So what would the A sub n be for that? For 2, 6, 8?
What'd you say, A sub 5? A sub 5 in your scenario is 16.
Yeah, so A sub n equals 5n minus 9. I'm not questioning that. I'm just saying.
I know you're not. I am. I don't know where you're.
N of that, of the 2, 6, 18, 54. What would it be?
Oh, any term?
Yeah.
A sub n would be 2 times negative 3 to the n minus 1.
That's it?
Yeah.
Okay, that's all I was.
There you go. Yeah. Again, common sense. Hang on just a second, Elena. If I'm going to get to any term, start with the first term, and you don't need to multiply by negative 3 18 times. You need to multiply by negative 3 17 times.
Why is it negative 3 not constant?
I changed it.
Oh.
I changed it. That's a great question. That would be real confusing. Yeah, if you didn't know I changed it. Okay, girls, watch this. Or I tell you what, do this. Take 8. Are y'all ready? Some people aren't ready. Some people are talking to their neighbor. Take 8, and you're just typing in on your home screen 8. Then go plus 4, plus what? 2. I'm doing geometric. What am I multiplying by? 1/2. My ratio is 1/2 right now. Okay? Plus 1 plus 1/2. Hit enter. 15.5. All right, let me use the new formula. The sum of 5 terms. Girls, that's called a partial sum. I think y'all clued into that and your discovery that I've sort of let you run with. Partial sum you've already seen, I think, in the book and on maybe a worksheet. A partial sum means I'm just going to go 5 into it. Somebody will tell you how far to go. So it's called a partial sum instead of the infinite sum. Okay? The partial sum, if I'm using my formula, would be a sub 1 times 1 minus r, which is 1/2, or I'll just do 1/2. 1/2 to the 5th power over 1 minus 1/2. You have to type these carefully into your calculator. So I would take my time. I wouldn't maybe try to full-fledged type that in my calculator all at one time. You might want to say 1/2 to the 5th in parentheses. Subtract it from 1. Multiply it by 8. And divide it by parentheses 1 minus 1/2. But do whatever you want to and see if you get 15 1/2. Do it your own way. Just make sure you're doing it correctly. Did everybody get 15? Lily got 15 and a half. Okay? Granted, there's the argument that, you know what, Miss Lazari, I'll just add up the 5 terms. Thank you very much, okay? But what if it was 50 terms? You'd be thankful for the formula, right? Everybody okay? 15.5, some way or another, your own way. Okay, let's keep going. So let's get, we were at 15.5, so let's just put that in because we know that's the first 5. So now you're clearing your calculator and put in 15.5. My next one is 1/4 plus 1/8, 1/16, 1/32, 1/64, 1/128, 1/256, 1/512, 1/1024, 1/2048, and tell me what you get. It's going to be more different than you suspect. It's got to have some sort of decimal to it, I think, unless I did something super weird. Did anybody else get that? 15.996?
I'm gonna also write that down overall.
I got 15.9995.
Is that what you got? What did you get flat on 16?
No, I just did the part, the one up there, because I figured
Oh, no. I want you adding up the numbers. Because, let me talk to that, Rebecca. Good point. You don't use that one, though. You don't use this one? Because this is an infinite. This is a set number of terms. Or you use this one. Did you use this one or this one?
I was using the bottom.
Okay, you can't use that one yet. You'll get the wrong answer. Because it's adding on more than this. Right now, I only have however many this is. So you have to use this one. You see what I mean? You're on the right track, obviously. Listen to their numbers. All right. So,
15.995. That's a really interesting graph.
isn't that great?
This is a little slow. Time to go back. Do we have it right after lunch? Now that I'm having that, let's just say and sign all
We skip back.
No, just
You'll be gone 2 hours before
no, but I feel like someone's walking me. You know?
Okay, girls, look. Look. Maybe. I don't know. I have a lot of people not looking, which I can't imagine why if you really tried last night's homework. You want to really understand what's going on in here, okay? So and I know I haven't gone over the homework. I definitely will go over all of that worksheet, okay? I mean, you don't need me to go over all of it. You have the answers, but I know there's some that you definitely need. And I'm not going to forget about that, I promise, okay? But you're going to also need all of this geometric information, okay? people that were watching were like, how'd you get that? Okay? Because now you realize that I could do this. And I think we're up to 15.
Yeah.
And you got 15. I think y'all got that number, right? Okay. Now I can do this and investigate it. Let's get ridiculous about it. Rebecca, I think you probably suspect what's going to happen here. So what happened? Okay, I'm going to show you where I got that. However, you're hungry for it? Okay, listen up. You're so hungry for that right now, like you're not even listening to me, like I want that sigma thing. However, you have to realize I had to know what to write behind it, right? So it's not as magical as it seems. You will be able to use it on the test, but it's not going to help you any more than, I don't think you'll be able to use the calculator for graphing things like tangent or cosine because you never know what kind of window you needed or how crazy it was going to look. It's easier to just do it by hand. So if you were able to use this, I have no trouble with it because you would have to know so much about sequences and writing formulas for them that would help you. So that's fine. I'll show you where it is later. But girls, I've only gone out to 150 terms, and it's already said 16. So let's go out to 1,500 terms. Okay, one thing I want you to notice, oh, by the way, just so you have a little window into calculus next year, this summation term, say a symbol, will actually eventually turn into an integral. This right here. Eventually, you'll actually be doing these funny looking things that you see behind smart people like in movies and stuff, okay? It's just the German S instead of the Greek S, but I say just. It's like so profound. It's like phenomenal. It's fundamental theorem of calculus, but let's move on. But it's really nice to know that before someone teaches it to you. It's a summation tool. All right, just like this is a summation tool right here that I just had on my calculator. You just did something remarkable. Like I just did something remarkable. You're going to do it also. We just added up an infinite amount of terms. You have to be really careful though. Rebecca and I were talking about what formula to use. If I wanted this sum of 15 terms, it would be 14.9995. That is the sum of those terms. That is a number that I might really need to know that I shouldn't round off, okay? But if I kept adding up the terms, eventually it's just going to settle in at 16. Before I say why, can somebody volunteer to tell us why? All right, Nicole?
Well, it's gonna the numbers are gonna continue getting infinitely smaller, so like it'll still go up, but because it's already like at like a pretty high decimal point, like it won't go. I don't know.
Isn't it that thing about like the repeating decimal that you were talking about, where like any repeating decimal for like the amount of digits, but in 9 is 1, so like 99 repeating. If you took 99 and put it over 99, it would be 1, but it's 0.99.
Perfect. That's exactly why. Lindsay?
Does that have anything to do with how 8 is 1/2 of 16?
No, that's interesting. Not right now. Boy, that's interesting. No, you can't like run with that. That's very interesting. Keep trying that and see what happens, okay? No one's ever asked me that before. So, I mean, math's all about patterns and noticing things. So let me tell you why that happens. Here's my thought on it. I wouldn't want to do it with 8 times 1/4. I would not get 32. Okay? For the infinite sum. Also, it doesn't really help you with 15, but if you're talking about always and forever, if you're talking this one, the reason that half happened is my ratio was 1/2, and what's 1 minus 1/2 is 1/2. Underneath an 8 would give you, it'll always work if the ratio is 1/2, but it won't work if the ratio is 1/16. But you could do the number over 15/16 because it's 1 minus the ratio. So just use the formula, it'll work for you. It will always work with 1/2, but it's just coincidence because
Yeah.
1 minus 1/2 gives you a 1/2 on the bottom, and then you flip it over and you double the number on top. So if the ratio is 1/2, but not if the ratio is 1/10. Okay? Hey girls, let's go back to what, go ahead.
Because like when you subtract, like the ratio is the same as like what you get on the bottom,
1 minus the ratio is what you get on the bottom,
which is the same. Yeah. Which is the same as the ratio.
if it's 1/2.
Yeah.
Okay. Girls, these numbers are getting so small. Please clear your calculator and put in 1/2048. And just somebody read out to me, Lily, what'd you get?
4.88.
E to the.
To the negative 4.
All right, so 0.000488. All right, now, did y'all know how to read that number?
Yeah.
Scientific notation. All right, so now put in 1/4096. All right, can y'all see right now that these decimals back here are going to change? But eventually these numbers are going to get so small. Let's do one like this. Type in 1/2 to the 10th. Tell me what you get.
9.7. Oh, 0. You want it in the.
You can give me scientific.
9.7. 6 e to the
Negative who?
negative 4.
4? Okay.
Yes. I got 9.766. You round.
Like this? Okay. So what's going to happen is eventually the numbers that you're adding on, well, I'll show you with a different one.
It's like, will it not change like from like the
After a while, it doesn't start to click over onto a new number. like
Right,
this.
because it won't have-
If I take, I don't know if I want to go that route right
Like in
now.
the tenths, the greatest we'll get is like 9.
13/99,
Close enough.
okay?
16.
13/99, sorry, that's 19. Divide 13 by 99. Do you get 0.13 repeating?
I learned about this.
So, and which is where Bella was headed. So you get 0.3 repeating, which is 0.13 plus 0.0013 plus 0.000013. If I add those up, do you see that eventually these numbers in the front aren't changing anymore? And it's starting to settle in. This is sort of like a watered down example. But what's happening with the one that we just did is eventually what's going to happen if you've got to 150 terms, they're going to be so tiny that as your numbers are clicking over to nines one at a time, that they just all end up clicking over to nines and they don't ever change to something bigger because there's never anything else in this row. Does that make some sense? Okay? So it just never clicks over and you're basically getting 15.9 repeating even though you're adding something. It's so teeny tiny at the bottom, which is interesting. Remember rational functions at the beginning of the year? Okay? This had a horizontal tangent at 0. Get a little free exam review right here. Okay? As I go out to infinity, I should have glasses with tape on them and put them on and go, the math number going, it never touches 0. Okay? Never touch. And I mean, some people would go, what? I mean, and I don't want you to touch 0, but how close is it going to get to 0? Infinitely close. It's going to get to be 1/903,487.
I know, it's like.
That didn't make any sense. Y'all see what I mean? Okay?
That's kind of such a frustrating topic. I know. And then when you do that at once, it's like just give that extra.
All right, girls, watch. So now people's brains are starting to run with that 13.99. Watch. Rebecca's going 1/3 as 0.3 repeating. So these decimals are really geometric sums,
Oh.
okay? By the way, all right? 2/3 is 0.6 repeating. Okay? Thank you for leading us down that path. Because this is 3/9. This is 6/9. Guess what 1/9 is? 0.1 repeating. Okay? What's 1/10 is flat 0.1. 6/10 is 0.6. Done. 3/10 is 0.3. Done. But 3/9 repeats.
So over 9 is just not quite there.
And so I knew if I did 13 over 90,
Going on forever.
13 over 99, I knew would give me 0.131313. What's 243 over 999 going to give you? 2.243, 243, 243, 243. Okay? All right, let's keep moving though. All right? Because I need to circle back to something that you really need to know for homework. Rebecca, I don't know if that's where you were headed though.
I was just saying, you could see that 0.9 repeating is 1 because if you add another third, it's 3/3, which is 1.
Oh, yeah, good point. If you add these together, you get 1. I've never done it that way. I love that.
Oh, I always think that like 9 over 9, if it's like this, you follow the same pattern, it's 0.999. but
That's
it's
where I was
actually
headed with it.
9
That's
over
really
9.
cool. Elena's right. Look, y'all look at this. 7 ninths is going to be 0.7 repeating. 8 ninths, if you type in your calculator, is going to be 0.8 repeating. If you do a geometric sum, you would figure that out. It would work right. Okay, just a minute. Hang on. Okay. All right. So let's stay with her. 9 ninths then would be 0.9 repeating. But girls, what's 9 ninths? It's 1. Okay, and I love what Rebecca said. 1/3 plus 2/3 is 3/3. It's definitely 1. 0.3 repeating and 0.6 repeating gives you 0.9 repeating. There's all sorts of ways to prove it's 1. It's a bit disturbing. I told you about Harry Potter Chronicles of Narnia Land. Okay. Okay, Lindsay, comment.
Okay, so like before when you gave us that example where it was like 15.5 something, but then you said like as time go on you would click to go to like the 999, which would then be 16. So like with that number, so then like that number would be like the same as 15.999 repeating, even though like it starts as less. Like they would both be equal to 16.
What both?
Like 15.99 repeating forever would be the same as like 15.5. Like that example you gave before was like 15.5, and then it was like over time it'd be like 99 repeating forever, which would make it 16.
Is that a question?
Yeah.
I don't know. Do you know what she's
What's the
asking?
Like would they would be equal because like you said before, like they would both be equal to 16, even though like at the beginning their decimals were different.
Okay, if I ask you for the sum of 5 terms, you say 15.5. If I ask you for the sum of 15 terms, you would get 15.9995. If I ask you for the sum of all the terms, it would be 16. So I have no idea what you're asking me. Does anybody know what she's asking me? Can
Okay, no.
Wait, repeat it. Like, slowly.
Like you gave us that example where like at the beginning of the decimal it was not 9, but then you said like over time it would become 9.
Oh, because
Therefore,
it
becomes
also
16.
slowly adds.
It's like partial sum versus total sum.
that's what I was
Like,
trying to
yeah,
say.
yeah.
Yeah.
They would both be equal to 16.
I don't know what both
No,
are.
because if you added all of them up infinitely,
Then it
well,
did.
there
That
would be
one's
so
16.
many times that it would be 16.
But like if you're given an amount,
Yeah,
then you're, it's equal to
we were
something.
finding
You
the
know
dial
what
where
an
it's
endpoint is.
To do with the adding fractions, they all slowly get like to the bigger and bigger sums. That would be
No.
with how like it ends up being.
I tell you what, in our last couple of minutes, I need to do some examples, okay? So Lindsay and I and all of you, we can talk about that later, but let me do a couple of real examples of what you're going to be doing out of the book. Girls, I am not forgetting that arithmetic worksheet, okay? Make sure you bring it to class. Your homework's going to be on geometric, But now some arithmetic might be woven in. I sure hope so. Okay, so be on the lookout for that. All right, so real quickly, here's one. Find the 15th term of the geometric sequence whose first term is 20 and whose common ratio is 1.05. And let's be completely quiet, Chloe, for a second while I grab my last couple of minutes, okay? You're not going to have any trouble with this, I don't think. You can use common sense or the formula. Either way, it's the same thing. I think to myself, to get the 15th term, I would start at the first term and multiply the ratio 14 times, type it in your calculator. I'm not going to show you where I got that sigma thing yet. I don't care about that right now, okay? But it'll be on my list of things to do. I will show you. The answer to that should be 39.60. It's in the book here, so I don't know what it rounds off to actually, but I always want 3 decimal places to get you ready for AP. All right? Another one is find a formula for the nth term of the following sequence. So I think, Elena, this possibly is, I've done a really poor job as a teacher today understanding your questions, but this may be what you were asking me, okay? To find any term, I'm going to start with the first term, and what are we multiplying by?
N minus 1.
Whoa, what are we multiplying by? 3 to the n minus 1,
Yeah.
okay?
That's what I was.
All right. Here's another one. The fourth term is 125. The 10th term is 125 over 64. Find the 14th term, and that's where things, I just seen you use common sense, okay? I got to 125 over 64 by doing, girls, hold still, okay? How many times did I multiply by something to get to the 10th term from the 4th term? 6 times, okay? So I would say I got here by multiplying this times something 6 times. Algebraically, you can then solve, okay? But be careful. Y'all see I would divide by 125, in fact, it would cancel? And in fact, the root of this, the 6th root of this, you'd end up with this. Watch. Shh. This is important. It's always important at the end, okay? You're going to get this, but the answer is actually this. An even root could be plus or minus. Couldn't I say negative 1/2, negative 1/2, negative 1/2 to get 164?
Yeah.
Watch out with an even root, because there might be 2 answers depending on where that lands. Okay? Homework will be more gentle. Okay? And bring your worksheet with you, and I'll post if I have a memo poster.
Thank you. Thank you, Sarah.
Bye, girls. Great discussion.